Hello everyone, in this video I'm gonna solve IBHL Mathematics Paper 1 questions from last year. In this year, Paper 1 will be at the 10th of November and Paper 2 is gonna be at the 11th of November and Paper 3 gonna be at the 14th of November. So it's better to solve these questions before taking exam in this year, and I hope this video will be helpful for everyone and wish you good luck. I will also share paper 2 and paper 3 questions from last year. So let's start with paper 1 questions from last year. You are not allowed to use GDC at the paper 1, and you can use formal booklet. Question 1. Points A and B lie on a circle with center O and radius R, where AOB equals 1.5 radians. This is shown on the following diagram. The area of sector OAB is 48 centimeters square. Find the value of R. You're not allowed to write here. I will use the next page. So what is the area of a sector? It is theta times R squared divided by 2. You can also check from the formal booklet. You don't need to memorize. And we know that theta is 1.5 times R squared divided by 2 equals 48. From here, you can use R squared equals 48 times 2 divided by 1.5, and which is R squared equals 48 times 2 times, let's write 2 over 3 because this is 3 over 2 and we reverse it. From here, R squared equals 64 and R equals 8. Yeah. At the question B, hence find the perimeter of sector OAB. OAB, right? Perimeter of OAB, which is 2R here, and the length of AB arc. So what is the length of arc? This will be theta times R, which is 1.45 times R, 8, and it equals 12. We can write from here, you know that R is 8 plus 12, and it's gonna be 28. Yeah, question two. Two events A and B are such that probability of A equals 0.65, PB equals 0.45, and union of A and B equals 0.85, and find intersection of A and B. So if we use the formula, which is union A and B equals probability of A plus probability of B minus intersection A and B. So we know that the union probability of union A and B is 0.85 and probability A is 0.65. Probability of B is 0.45, and from here 0.85 equals, if we add each other, it's gonna be 1.1 minus probability of intersection A and B. In this case, probability of intersection A and B equals 1.1 minus 0.85, which is 0.25. So this is conditional probability. I will write out of A the probability of it's like it's given that probability of out of B, and from here we will find the probability of out of A. What is this? At the denominator, you will write probability of out of B. At the numerator, you will write probability of intersection out of A and out of B. It's better to check it from the Venn diagram. You know that the intersection 0.25 and the probability of A 0.65. So in this case, you can write 0.4 here. And probability of B is 0.45. And here is 0.2. Since the probability of B equals 0.45, the probability of out of B is going to be 1 minus 0.45 because the total probability B and out of B is going to be 1. From here, you can write 0.55 out of B. 0.55, and we need the intersection of out of A and B. This is out of A, and let's check out of B. So what is the intersection yellow and blue? It's gonna be out of A and B, right? Out of A and B. Yeah, we are looking for this. In this case, we can use 1 minus, what's the probability of union? 0.85, which is 0.15. Yeah. So let's use it. Since you are not allowed to use GDC, we will just write, maybe you can cancel 5 from each other, which is going to be, first we can write 15 over 55, and it equals 3 over 11. Question 3, prove that 3 times n plus 2 square minus 3 times n minus 2 square is a multiple of 12 for all n integer, positive integer. Let's say so I will write the complete square of 3n plus 2, which is 9 times n square plus 12n, because I know that if a plus b square equals a square plus 2 times a and b plus b square plus square of 2 is 4 minus, I will write in parentheses, 9n square minus again 12n plus 4 square of 2, which is 9 times n square plus 12 times n plus 4 minus 9 times n square. It's going to be positive 12 times n minus 4. You can cancel these expressions. Sorry, not this one, 4. And it will be 24 times n, which is multiple of 12. At the question 4, the following diagram shows triangle ABC where AB 4, BC 6, AC 5 centimeter, and ABC angle is 2 times theta. Find the exact value of cos theta, giving your answer in the form like this. Yeah. So I'm going to use the cosine formula. What was that? It is 5 square equals 4 square plus 6 square minus 2 times 4 times 6 times cosine 2 times theta. From here, you can write 25 equals 16 plus 36 minus 48 times cosine 2 theta, and which is 48 times cosine 2 theta equals 52 minus 25, So cosine 2 theta equals 17 divided by, sorry, 27 divided by 48. It is 9 over 16. So we also know the double angle formula. Cosine 2 times theta equals uh, 2 times cos theta square minus 1. So if you write 9 over 16 equals 2 times cosine theta square minus 1, from here you can write cosine theta square equals 9 over 16 plus 1 divided by 2, right? So cos theta square equals 25 over 32, and cosine theta equals square root of 25 over 32, 5 over 4 times square root of 2, and this is also 5 times square root of 2 divided by 8, and in this case P equals 5, Q equals 8. Question 5. For a particular arithmetic sequence, U10 equals 16 and S25 equals 100, find the value of k such that UK equals 0. So what is S25? It is sum of the first 25 terms. It equals 25 over 2 times U1 plus U25. It equals 100. U1 plus U25 equals 200 over 25 equals 8. So I will write all of these terms in terms of U1. For example, U25 equals U1 plus 24 times D, which is distance between each term. And U10 also equals U1 plus 9 times D. You can also write U1 plus 25 times D equals 8, which is 2 times U1 plus 24 times D equals 8. And U10, for U10, you can also write U1 plus 9 times D equals 16. If we cancel U1 and multiply it by minus 2, it is 24 times D minus 18 times D equals 8 minus 32. So 6 times D equals minus 24, D equals minus 4. From here, you can find, for example, that U1 plus 9 times D equals, which is U10, 16, and U1 plus 9 times minus 4 equals 16, and U1 equals 16 plus 36, 52. We are looking for the UK, which equals 0. So for UK, you can write U1 plus k minus 1 times D. It's going to be 0. We know that U1 is 52 plus k minus 1 times, and D is minus 4 equals 0. So 52 minus 4 times k plus 4 equals 0. So 4k equals 56 and k equals 14. Question 6. Solve 2x squared minus 15x plus 18 less than 0. This is quadratic inequality. We're going to factorize this first. So how are we going to factorize? And we need to write the factors of 2 times x squared, which is 2 times 6 and x, and also 18. But there are some factors. How we're going to decide, for example, 3, 6, and 2, 9, minus 3, minus 6. And it can also change the place. The question is, when you cross product these numbers, for example, 2 times 6 and plus 3 times 6, it needs to be minus 15 times 6. So this one is not equal. But when you choose, for example, minus 3 and minus 6, you can see that 2 times 6 times minus 6 plus minus 3 times 6 equals minus 15x. We will just use minus 3 and minus x, 6. The factors of this quadratics is 2 times 6 minus 3 times x minus 6. So when you decide to write out the factors, you need to write in a straight way. It should be less than 0, and I need the zeros of this quadratic, which is 3 over 2 and 6. And we are drawing the sign table. The sign is starting by positive because the coefficients of x, both of them is positive. And we know that at the roots is changing the sign, minus and positive again. So we are looking for the negative range, and the solution is 3 over 2 between 6. Yeah. At the question B, there is f of x, square root of the same quadratics. I wrote the same quadratics here. And x is a real number and less than k. Find the greatest value of k for which inverse of f exists, justifying your answer. The attribute of square root, the inside of square root should be greater or equal 0 than 0. So we already factorize these numbers like this. When you draw the sign table again, now we are looking for the positive range. I mean, there are two range here. But since we're looking for the x, which is less than k, so this one is appropriate for our solution. In this case, k is 3 over 2, but it says inverse of f exists, justify your answer. Maybe you can just try to draw this graphic. We know that square roots are starting from the x-axis and going to the infinity, for example, from 6 to the infinity, from 3 over 2 to the infinity. And this y-intercept is if you, for example, write 0, I mean substitute 0 into the f of x, you will see that this is square root of 18. So here is square root of 18. Here is 3 over 2, and here 6. So we choose, in this case, the left side of the graphic. And here is 1 to 1. You can mention that the function is 1 to 1. You can justify it by horizontal test. At x or at the range uh, minus infinity and 3 over 2, then inverse of f exists. You can write something like this. K is 3 over 2. Question 7, consider the function f of x equals secant x minus pi over 4 for x between 0 and pi over 2. Determine the range of f. F of x equal secant x minus pi over 4, and our domain is between 0 and pi over 2. Yeah, I'm checking the values. If we substitute, for example, 0, secant 0 minus pi over 4, which is secant pi over 4, or first right, minus pi over 4, which is 1 over cosine minus pi over 4. So we know that cosine is at the same and the negative and the positive side. It's 1 over cosine pi over 4 is square root of 2 over 2, which is 2 over square root of 2 equals square root of 2. And if you substitute, for example, pi over 4, secant pi over 4 minus pi over 4 secant 0, and it equals 1 because cosine 0 is 1. And also if you substitute pi over 2, it's going to be secant pi over 2 minus pi over 4, secant pi over 4, the same here. You already found it, square root of 2, right? From here, it's better to know some fundamental graphics, sine, cosine, secant, tangent. And if you draw this graphic of secant, and our domain is between 0 and pi over 2, in this case, we substitute 0 and we found it square root of 2 at 0, and at pi over 4, we found it 1. The output is 1. So when we substitute pi over 2, output is square root of 2, same here. So our graphic is like this, right? Yeah. From here, you can say that the range of this function f is the range is between 1 and 1 and square root of 2, right? Yeah. What's the question B? Find the region bounded by the graph of f of x, the x-axis, and the lines x equals 0 and x pi over 2 is rotated 2 times pi radians about the x-axis. Find the volume of revolution generated. So it's asking for the function x-axis, x equals 0, which is y-axis, and x equals pi over 2. This is the region. And we rotate it by 2 times pi radians about the x-axis, right? So this means there's integral here, because if you find the volume of this region, you need to write, you can also check from the formal booklet, and you will see our limits is from 0 to pi over 2, from 0 to pi over 2. Into the integral, you need to write pi times f square dx. So let's calculate. By the way, you can also write pi out of the integral, and our function is here, secant x minus pi over 4 square dx. So what is the integral of secant square? You will see that from the formal booklet, it says tangent. Tangent, yeah, x minus pi over 4, and our limits is from 0 to pi over 2. Yeah, that's it. And we will substitute these values. First, tangents pi over 2 minus pi over 4 minus tangent 0 minus 0 pi over 4, which is pi times tangent pi over 4 minus tangent minus pi over 4. So this is pi times tangent pi over 4 is 1, minus, this is also minus 1, equals 2 times pi. Question 8. The following diagram shows 2 points A and B such that OA, the vector OA equals A, the vector OB equals B, and the point P lies on AB so that AP equals lambda times AB, where lambda between 0 and 1. Show that OP equals 1 minus lambda times A plus lambda times B. So yeah, OP vector is, you see that here OP equals the addition of OA and AP, right? You can write OA plus AP. OA is equals A plus, and AP equals lambda times AB. From here, you can write A plus lambda times AB is means B minus A. And from here, you can write A plus lambda times B minus lambda times A. If you write in common factor by A, it's gonna be 1 minus lambda plus lambda times B. Yeah. It's given that the magnitude of A equals 1, magnitude of B equals 2, and A times B equals 1 over 4. In the case that OP is perpendicular to AB, find the value of lambda. So if OP vector perpendicular with AB means the scalar product of these two vectors gonna be 0. And we know that OP, in the previous question, we found that A times minus A times 1 minus lambda plus lambda times B. And we're gonna multiply it by B minus A, because AB vector means B minus A. So let's multiply it by first A times B times 1 minus lambda minus A times A times 1 minus lambda plus lambda times B minus lambda times B times A equals 0, right? So in the question, it's given that A times B is 1 over 4. And what is A times A? A times A, this is vector, means model A times magnitude of A times cosine 0, because I know that if the vector is same, it means the angle between these vectors, since it's same, it's gonna be 0. So you can write from here, this is the square of magnitude, and we know that the magnitude of A is 1. In this case, you can write 1 square. Same for B, square of 2 minus again lambda times 1 over 4, which is 1 over 4 minus lambda over 4 minus 1 plus lambda plus 4 lambda minus lambda over 4 equals 0. You can first make 1 over 4 minus 1, which is minus 3 over 4. And then here is 5 lambda. And these are, it's gonna be minus lambda over 2. It's gonna be 0. So 3 over 4 equals 9 lambda over 2. And lambda from here you can write 6 over 36, which is 1 over 6. Question 9, prove that tangent theta minus pi over 4 equals sine 2 theta minus 1 over cosine 2 theta. And so we will remember that or check from the formal booklet what is tangent theta minus pi over 4. It is tangent theta minus tangent pi over 4 over 1 plus tangent theta times tangent pi over 4. From here you can write tangent theta minus 1 because we know the tangent pi over 4 is 1 over 1 plus tangent theta, right? So if you replace tangent theta with sine theta over cosine theta minus 1 over 1 plus sine theta over cosine theta, we will find sine theta minus cosine theta over cosine theta over cosine theta plus sine theta divided by cosine theta, which is, these are cancel each other, sine theta minus cosine theta divided by cosine theta plus sine theta. So if you also multiply it both sides by sine theta minus cosine theta, we will find at the up sine theta minus cosine theta square divided by sine theta square minus cosine theta square, right? Sine theta square minus 2 times sine theta times cosine theta plus cosine theta square. And this is double angle formula minus cosine 2 theta equals. At the numerator, you will find that since sine square plus cosine square is 1, you can write 1 here, minus, and also double angle attribute, you will see that this is sine 2 theta divided by cosine 2 theta. You can also write sine 2 theta minus 1 over cosine 2 theta, right? Yeah. The question B, hints or otherwise solve sine x minus 1 divided by cosine x equals square root of 3. Yeah, we know the formula, which is tangent theta minus pi over 4 equals this expression. In this case, we can write tangent pi over 3 instead of square root of 3. We need to find theta. So theta minus pi over 4 equals pi over 3. From here, theta equals pi over 3 plus pi over 4, which is 7 times pi over 12. In this case, you can write tangent 7 times pi over 12 minus pi over 2 equals sinus the double of this angle, 7 times pi over 6 minus 1 divided by cosine 7 pi over 6. So x equals, let's ask for x, right? Yeah. X equals 7 pi over 6. This is section B. These questions in here have the highest marks, so we need to be careful. For example, this question has maximum mark 17. Start with this. Consider a cylinder of radius r and height h. A smaller cylinder of radius r is removed from the center to form a hollow cylinder. This is shown in the following diagram. All lengths are measured in centimeters. The total surface area of the hollow cylinder in centimeters square is given by S. The volume of the hollow cylinder in centimeter cube is given by V. Show that S equals 30 times pi times r square plus 10 times pi times r times h. I will copy this question. To start by A. Yeah. So what is the surface area of a cylinder? We know that the cylinder, if you open it, you're gonna face a rectangle and two circle. In this case, you can also, by the way, check from the formal booklet. So we can first start by, and the big radius is 4r in this case, and the height is h. Here is the perimeter of the circle, which is 2 times pi times 4 times r, the radius. We're gonna write 2 times pi times 4r times h for the rectangle. Just be careful because let's think that this is the cover, and we take off this small circle from the cover. Pi times 4r square minus pi times r square. We found this area, and there is 2 from this. Inside of the cylinder, there's a gap, and I'm gonna also calculate this area, which is inside. So it will be the same like here, 2 times pi times r times h. So this is gonna be a times pi r h plus, it's gonna be 15 pi r square times 2 pi r h, which is 10 pi r h plus 30 pi r square. Yeah, this is the question A. At the question B, the total surface area of the hollow cylinder is 240 pi centimeters square. Show that. Yeah. So at the question B, the total surface area of the hollow cylinder is 240 pi. 240 pi. We already found this equation here from the surface area, which is 10 pi rih plus 30 pi r square. You can cancel pi and then divide it by 10 each expressions. So 24 equals r times h plus 3 times r square, right? We're gonna use this equation. And what was the volume of a cylinder? The volume is, you can also check from the formal booklet, base area times height. So what is the base area of the cylinder? It is pi times 4r square minus pi times r square times h, right? Uh, 16 pi r square minus pi r square times h, 15 pi r square times h. So I need to write h in terms of r from this equation. We're gonna use 24 minus 3 times r square equals r times h. H equals 24 minus 3 times r square over r. I will use it in volume formula. In this case, volume equals 15 times pi r square times 24 minus 3 times r square divided by r. We can cancel r in here. And then 360 pi r minus 45 pi r, the third power, yeah. At the question C, it's asking for find an expression for this is the derivative of the volume in terms of r. So I'm gonna find it. Or first write what's the equation of the volume. We found it 360 pi r minus 45 pi times r to the third power. So what is the derivative of the volume in terms of r? It's gonna be 360 pi minus 45 times 3 times pi times r squared, because we are decreasing by 1 the power of this r. It's going to be 360 pi minus 135 pi times r squared. And keep going by question D. The hollow cylinder has its maximum volume when r equals pi times square root of 2 divided by 3, where p is a positive integer. Find the value of p. So we found the derivative of the volume in terms of r, which is 360 pi minus 135 pi r squared. If we are looking for the maximum volume of the cylinder, this expression gonna be equal to 0. We're gonna find this r. Let's find it. We can cancel this pi. So 360 equals 135 r squared. R squared equals 360 over 135. You can divide it by 45, both numerator and denominator. It's gonna be 8 over 3. Let's say square root of 8 divided by 3, which is 2 times square root of 2 divided by square root of 3. We can mention that p is 2. But how are we gonna know that this is the maximum point of this function? There is also negative 2 times square root of 2 over square root of 3. So if we write in sign table these values, and you can decide which one is maximum and which one is minimum. For example, this is our function. We know that the right of this value is gonna be minus, and here it will change its sign, will be positive, and then again negative. So the derivative, I mean the function is decreasing and increasing here. This is the point of maximum because it's changing from increasing to decrease. That's why this value is the maximum point. At the question A, it's asking for hints find this maximum volume, giving your answer in the form like this. So we will just use this value, which we found in the previous question here, R, in the expression of the volume. So let's not this one. This is derivative of the volume. I mean this volume equation. It is 360 pi r minus 45 pi r to the third power. And we found r is here. So 360 pi times 2 square root of 2 over 3 minus 45 times pi times the third power of 2 times square root of 2 over 3. Yeah. So let's find this. This is 720 pi square root of 2 over 3 minus 45 times pi times 8 times it's gonna be 2 over 3 square root of 2 over 3. You find the third power of this expression, the number. From here, you can find 720 pi square root of 2 over 3 minus, it's gonna be 140 pi square root of 2 over 3, which is 480 pi square root of 2 over 3. And yeah, so Q is 480. Question 11, it has maximum 70 mark. The curve is given by the equation. You see the equation. Question A, asking for by applying L'Hopital rule or otherwise show that this limit equals 1. Yeah, start by this. I'm going to copy from here. At the question A, limit x approach to infinity, a to the power of 2 times 6 minus 1, a to the power of 2 times 6 plus 1. We can apply the L'Hopital rule. What's that? We're going to find the derivative of numerator and denominator. And by the way, you are keep going to apply the limit of the function. Just find the derivative of the numerator, which is 2 times a to the power of 2 times 6 minus the derivative of this 2 times a to the power of 2 times 6, because we know that the derivative of the constant is 0. In this case, they are cancel each other, and the equation is gonna be 1. Show that the derivative of the function is this. First, I'm writing the function again, and yeah. So what's the derivative of this function? We're gonna apply the quotient rule. The quotient rule is, I'm just first finding derivative of the numerator, which is 2 times a to the power of 2 times 6 times the denominator, a to the 2 times 6 plus 1 minus numerator, a to the power of 2 times 6 minus 1 times the derivative of the below, which is 2 times a to the power of 2 times 6, and the square of the denominator. Simplify this expression. Uh, we can write 2 times a to the power of 4 times 6 plus 2 times a to the power of 2 times 6 minus 2 times a to the power of 4 times 6. I'm multiplying by this because plus 2 times a to the power of 2 times 6 divided by a to the power of 2 times 6 plus 1 square. From here, you can see that these expressions cancel each other, and The other one is gonna be 4 times a to the power of 2 times 6 divided by a to the power of 2 times 6 plus 1 square. Yeah, this is the derivative of y. We show that 1 minus y squared equals the derivative of y. The second question of B. Uh, what is 1 minus y squared? We know that y is a to the power of 2 times 6 minus a to the power of 2 times 6 plus 1 square. What's that? 1 minus a to the power of 4 times 6 minus 2 times a to the power of 2 times x plus 1 divided by a to the power of 4 times 6 plus 2 times a to the power of 2 times 6 plus 1. We can write from here a to the power of 4 times 6 plus 2 times the same with the denominator minus a to the power of 4 times 6 plus 2 times a to the power of 2 times 6 minus 1. We can write a to the power of 2 times 6 plus 1 square at the denominator. So these are again cancel each other and 1 also. So it equals 4 times a to the power of 2 times 6 divided by a to the power of 2 times 6 plus 1 square. It was the derivative of y. Yeah, I'm looking for the other questions. By using implicit differentiation and the result in part B2 show that what we found in part B2, we found it first, let's write the question. We found it 1 minus y squared equals derivative of y, right? Yeah. So we will use implicit differentiation. We're gonna again apply the derivative. So start by this. The constant derivative of the constant is 0 minus 2 times y. We decrease the power of this function by 1. And then we are not forgetting to find the derivative of this function also y prime. And also, we are also applying the derivative at the right side. It's going to be the second derivative of y, right? Yeah. And from here, you can write minus 2 times y times what was the derivative of y. We can also write this 1 minus y squared, which is minus 2 times y plus 2 times y to the power of 3 equals second derivative of y. Yeah. And the second question is find an expression for the third derivative of y in terms of y. Again, we're going to apply the implicit differentiation. So I'm writing again what we found in the previous question. This is the second derivative. And we again apply the derivative. We will find minus 2 times y prime plus 2 times 3 times y squared times derivative of y equals the third derivative of y in terms of x. So we again substitute the expression of derivative of y, which we found it in here, 1 minus y squared plus 6 times y squared times 1 minus y squared. Let's simplify this expression. Minus 2 plus 2 times y squared plus 6 times y squared minus 6 times y to the power of 4. Again, if we simplify this, 6 times y to the power of 4 plus 8 times y squared minus 2. So this is the third derivative of y. Yeah. At the question D, by using your result from parts B and C, find the Maclaurin series for the function up to and including the term in x to the power of 3. So what is the Maclaurin series? It's starting by the f of 0 plus the first derivative of f at 0 times x divided by 1 factorial plus the second derivative of f at 0 times x squared divided by 2 factorial plus the third derivative of f at 0 times x cubed divided by 3 factorial. F0, you will write in here. If you write 0 in here, it's gonna be a to the 0, 1, it's gonna be 0, right? F0 is 0. And what is the first derivative of f at 0? We found it, the first derivative in here, and if you substitute 0 in here, you will find 1 because 1 minus 0 is going to be 1. At the second derivative at 0, the second derivative we found it in here, so it was 0. The same is going to be 0 because y was 0 at when we substitute 0. At the third derivative, let's check it. We found third derivative in here. Here is going to be 0 and minus 2, right? Yeah, minus 2. So let's plug into this expression in here. F0 is 0 plus 1 times x plus 0 times x squared. This is going to be 0. You don't need to write it, but the third derivative was minus 2 times x cubed divided by 6. So if you simplify this expression, it's going to be x minus x cubed divided by 3. Question 12, it has maximum 20 mark. Consider the equation that to the power of 4 equals 16 times I, where z is a complex number. The equation has 4 roots, z1, z2, z3, z4, where zi equals, this is the polar form of the complex number, and r greater than 0. Yeah, let's find the roots of this equation. Yeah. So I'm writing the equation again, z to the power of 4 equals 16 times I. We need the polar form of a complex number. What's the polar form? For example, if there is a z equals a plus b times I, you can write in the polar form that r times c is theta. We call it a, the real part, and the imaginary part is b. And we know that the angle is theta here, and this is the magnitude of this complex number. In this case, uh, if this is 16i, it means on the imaginary axis here, this is 16, and the angle is 90 degree. We can write in the form 16 times c is pi over 2. Yeah, you can also prove it like cosine pi over 2 plus I, because cis theta means r times cosine theta plus I times sine theta. In this case, you can write I times sine pi over 2. Here is 0, here is 1. So this is correct. By the way, since we are looking for the roots of this equation, we need to write in the form of plus 2 times k times pi, where k is an integer number. You can also simplify this equation like pi plus 4k pi divided by 2, right? So when we want to find the root of this complex number, we're gonna uh, find 1 over 4 power of this complex number. It means you will also divide the angle of this complex number by 4. So in this case, that's gonna be 2 times 6 pi plus 4 times k times pi divided by 8. From here, you can write, if you substitute 0 into the k, you will find the first z, the first root, 2 times 6 pi over 8. And the second z, the second complex root, is gonna be 2 times 6 5 pi over 8. The third one gonna be 2 times 6 9 pi over 8. And the fourth root is gonna be 2 times 6 uh, 14, 13 uh, pi over 8, right? Uh, by the way, we call it here the Moore theorem. It's better to write it. Yeah. At the second question, the roots Z1, Z2, Z3, and Z4 form a geometric sequence. Find the common ratio of the sequence expressing your answer in the Cartesian form. Uh, yeah. So let's say Z1 is 2 times 6 pi over 8, and Z2 2 times 6 5 pi over 8. If these are the terms of the geometric sequence, the ratio gonna be Z2 divided by Z1, which is 2 times 6, 5 pi over 8, 2 times 6, pi over 8. From here, cancel 2, and this is 6, 5 pi over 8 minus pi over 8, 6, 4 pi over 8, 6 pi over 2. So we can also write cosine pi over 2 plus I times sine pi over 2, which equals I. So yeah, at the question C, it's asking for we will show this rules respectively on an Argand diagram and plot the points ABCD on an Argand diagram. Uh, let's draw this. This is the real part and this is the imaginary part. Z1 is here with the angle of pi over 8 and the magnitude is 2. All of them the same magnitude. This is Z2 There is 90 degrees each between Z1 and Z2, and Z3 gonna be here, again 90 degree between Z2 and Z3, and Z4 is gonna be here and 90 degree between each other. Yeah, like this. The equation v to the power of 4 equals a plus b times I, where v is a complex number, ab is a real number, has roots. This is the conjugate of this roots, the complex numbers, determine the value of a and the value of b. So, uh, you know, for example, what is the conjugate of a complex number? Let's say if z is a plus b times I, the conjugate of z is gonna be a minus b times I. So the sign of this imaginary part is changing. In this case, uh, we can say that the conjugate of z1 is gonna be, uh, let's say, first positive and then negative. You can also say 2 is minus pi over 8, because this is also 2 times cosine, 2 times cosine pi minus pi over 8, plus pi times sine minus pi over 8, 2 times, I know that cosine will be same with the negative uh, sign. It's gonna be the same with the positive, and the sine will be negative if the degree is negative, pi times sine pi over 8. So we can see from here the imaginary part, the sign of the imaginary part is changed. In this case, we can write into this equation, if this the conjugate z1 is the root of this equation, we can say that the power of the fourth power of z1, which is 2 over, I mean 2 to the 4 times 6 minus pi over 8 times 4, it's gonna be a plus bi. From here you can write 16 times 6 minus pi over 2, which is 16 times cosine minus pi over 2 plus I times sine minus pi over 2. It equals 16 times 0 minus I times 1 equals minus 16 times I. So we found if this is v to the 4 power, in this case a equals 0 because this is 0 plus minus 16i, and b equals minus 16. The last question, the midpoint of AB is A prime, the midpoint of BC is B prime, the midpoint of CD is C prime, and the midpoint of DA is D prime. Consider the equation v to the power of P equals 2 to the power of Q, where uh, W is a complex number, P and Q is a positive integer. Four of the roots of W to the power of P and to the power of Q are represented by the points A prime, B prime, C prime, and D prime. Find the least possible value of P and the corresponding value of Q. So, what's the midpoint of this complex numbers? We know that A was here, right? Yeah, we call it plot the points A, B, C, D. We can write in here A, B, C, D. It's gonna be B. So I know that there is 90 degrees each between these complex numbers, and we are looking for the midpoint of A and B, which we're gonna call it A prime. So what is uh, this complex number? You can see from here, it's gonna be also perpendicular to the AB uh, line, and AB, the length of the AB is gonna be 2 times square root of 2 from the Pythagorean theorem. And in this case, the magnitude of A prime also be square root of 2. For example, you can write A prime square root of 2 times 6. Let's find the angle. It was here pi over 8. And this gonna be the half of the 90 degrees, or pi over 2, which is pi over 4. In this case, you can write pi over 4 plus pi over 8, which is square root of 2 times is 3 times pi over 8, right? Maybe we don't need to find the other roots because we are checking for uh, which power of, for example, A power, this is also P, gonna be equal is an integer, also the power of 2. Find the least possible value of P. From here, you can write square root of 2 to the power of P. C is 3 times pi over 8 times P from De Moivre theorem. And this needs to be equal the power of 2. For example, what we'll see is cosine 3 times pi over 8 times P plus I times sine, again 3 times uh, pi over 8 times P. So we are looking for a real number, not an imaginary number. In this case, we need to cancel this part. So when sine gonna be 0, uh, we know that sine uh, alpha equals 0, where alpha is, for example, pi times k, the multiple of pi. Yeah, from here to cancel the 8 at the denominator, maybe we can choose to write uh, 8 to plug in P. But when you choose 8 to plug in P, in here it's going to be cosine 3 times P, which is -1. But our number 2 to the power of Q is not negative. It needs to be positive. In this case, 8 is not enough. We will choose the other multiple of 8, which is 16. P is 16. In this case, you can see from here square root of 2 to the power of 16 times cosine 3 times pi over 8 times 16 plus, I'm not writing here, it's already gonna be 0, which is 2 to the power of 8 cosine 6 times pi plus 0. It means 2 to the power of 8 because cosine 6 times pi is 1. So Q is 8. And we finish paper 1 questions and see you at the paper 2 solutions. Bye bye.